So I want to look at acid rain in this video. Now there's two places acid rain can come from. The first is coal-fired power stations, and the second one is car engines and things like that. So coal-fired power stations first. Right, so if we were to draw a quick diagram of this, a coal-fired power station, quite a simple thing. It takes coal, burns it, generates heat. That heat is used to boil water into steam, and that steam is then fired at a turbine. A turbine is just essentially a propeller, and the steam being jetted as it turns it around, and that turns the electromagnet and the coil of wire. So the out of the chimneys of the coal-fired power station comes the waste gases from the burning of the coal. Now, coal is, let's just make some figures up to make a point, 99% carbon. Okay, so when that coal-fired power station burns the 99% carbon, it reacts with oxygen in the combustion process. And out of these chimneys here, okay, comes mainly, but not totally, mainly carbon dioxide. So the carbon reacts with oxygen, makes carbon dioxide. But of course, coal is not pure carbon. It contains, say for sake of argument, now there's different qualities of coal. But let's just say for sake of argument, it contains 1% sulfur as an impurity. Now, when the sulfur burns in the coal-fired power station, it also oxidizes. But it's mainly carbon dioxide and some sulfur dioxide, SO2, out of these chimneys here. Okay, now above, up in the sky, we have some nice clouds, which are of course water. So what we get now is this sulfur dioxide going into these clouds, where it dissolves in the water, and so we then end up with a mildly acidic cloud, because sulfur dioxide and water, when it dissolves, makes sulfuric acid. Now, we used to burn a lot of coal in coal-burning power stations in the UK in the 1980s. When I was growing up, I think it was close on 80% of the electricity in the United Kingdom was generated by coal-burning power stations. So we were generating a lot of sulfur dioxide at the time. Now, most of the wind in the United Kingdom comes from the west and heads off towards the east. Okay, so it heads off towards the east. Now, east of the United Kingdom is Scandinavia, Norway and Sweden. So we used to export, in the best possible way, lots of our sulfuric acid clouds to Norway and Sweden, where they rained. Now, that was great for us, because it wasn't raining on us. Okay, but if you lived in Norway at the time, you were mildly displeased with us, to say the least. Okay, so what does it do in Norway? It killed the fish. Okay, fish in rivers and lakes can be tremendously sensitive to a change in the pH of the water. So the acid didn't kill them, but what happens when the pH changes is other chemicals can start to come out into the water, and that did kill a lot of fish. It weakens trees. Now, the acid rain is only very dilute. Okay, it's very, very dilute indeed. So it didn't kill the trees, it just weakened them. And when they're weakened, they're more susceptible to disease. They're more susceptible to strong winds. So they do end up dying, and in some cases, and so the trees are also an issue. And it erodes limestone buildings. Limestone, very, very common rock. Cathedrals often built of limestone because it's common. It's also easy to work. Okay, so the sign here, if it was a limestone, would start to erode over time. So 3 issues. 1, erodes limestone buildings. Okay, kills fish. 2, kills fish. 3, weakens trees. 3 issues of acid rain. Okay, how do we solve it? How do we solve it in the 80s? Because, of course, the Scandinavians got really fed up with us. If we, into these chimneys here, spray calcium carbonate. Now, calcium carbonate, very common rock. Just told you that, haven't I? Okay, used for making cathedrals and statues and things. Well, you can also grind it into a powder and spray it into these chimneys. The spray makes it wet, so the sulfur dioxide dissolves in the water. So we get the sulfuric acid in the chimneys. Calcium carbonate is, of course, a metal carbonate, so that neutralises acids. So we can neutralise this acid emissions in the chimneys of the power stations and stop all this stuff. That's one way acid rain is formed. Next way, nitrogen oxide can be formed. So sulfur oxides are one way acid rain is formed. Nitrogen oxides, formed in car engines. They can form in hydrocarbon fuels, petrol and diesel. Yes? Petrol and diesel are burnt. Where does the nitrogen come from? The answer is the air. The car engine, sucks in. The car engine, let's quickly sketch a car. I'm an appalling drawer. Let's put a spoiler on the back of it, that way we know it's the back, don't we? Okay, here's the exhaust pipe at the back. And we need a wheel there, I suppose, and a wheel there. Okay. All right, so here is the engine here. The engine is very, very hot. Okay, the engine is very, very hot. Now, the engine sucks in air. Now, remember, the air is 80% or 78%. 80% nitrogen and 20% oxygen. 21% oxygen to be precise. Okay, now that air, reacts with petrol from the tank here. That goes into the engine as well. And out of the exhaust, of course, mainly comes carbon dioxide and water, because that's the product of complete combustion of a hydrocarbon. Having said that, this is so hot in here, we get an unwanted and a competing side reaction. Now, that's one of the reasons you never get 100% yield in chemical reactions. There's three reasons, of course, if you remember back to percentage yield. One is reactants are lost, another one is products are lost, another one is unwanting or competing side reactions, or the reaction not going to completion, however you want to describe it. Now, the unwanting or competing side reaction is the nitrogen in the air, reacts with the oxygen in the air instead of the petrol, making nitrogen oxides. So out of this exhaust here, you also get these things as well, NO. I'm going to put X there because you can get NO, nitrogen monoxide or nitrogen dioxide, things like that. So making nitrogen oxides. Now those nitrogen oxides then go up into the clouds. And if sulfur oxide makes sulfuric acid, nitrogen oxide there makes nitric acid. Goes off to Norway, kills their fish, makes them unhappy. How do we fix that one? If we could fix the acid rain by the sulfuric acid rain by putting calcium carbonate into the power station chimneys, how do we solve this one? We solve this one with catalytic converters. So all new cars from 1990 have to be fitted with catalytic converters. And it's solved an awful lot of those problems. Formation of nitrogen oxide, balanced symbol equations, that's nitrogen plus oxygen, nitrogen monoxide, NO. Two nitrogens, one nitrogen, two there. Two oxygens, about two makes two oxygens there. Right, a balanced symbol equation for formation of nitrogen dioxide. So that's N2 plus O2, nitrogen dioxide, NO2 this time. Di means two, dioxide, two oxides. So two nitrogens, we need two nitrogens there, don't we? Two oxygens, 2 times 2 is 4 oxygens there, so we need 4 oxygens there. And that is acid rain.